Hi friends, one last quick part. We're going to do a little bit of lesson 6 here in Unit 5. We're not going to do the whole thing. It's taking that Pythagorean identity and extending it to some more information. So maybe you just want to remind yourself that we're talking cosine squared plus sine squared equals 1. That's our Pythagorean identity. Our math talk just starts to warm us up with which quadrant we're in. And it may be helpful. We know we put it on our unit circle, so maybe it's already on your page that you have tabbed, where we've written some of our information about quadrant 1, quadrant 2, quadrant 3, and quadrant 4. But we shouldn't have to always go back to that page to keep that in mind. Okay, so just remembering some things like everything to the right of our y-axis has a positive x coordinate, and everything to the left of the y-axis has a negative x coordinate. I hope I said that right. Everything to the right of y-axis is positive x's. Everything to the left of the y-axis is negative x's. Same thing holds true when we're talking about our x-axis. Everything up above it is a positive y. Everything below the x-axis is a negative y value. So being able to do that very quickly is just some common sense when we're starting right there with our origin, and we're good to go. So for an angle in each of these quadrants, use mental estimation to identify the values of cosine, sine, and tangent as either positive or negative. Now so far we've talked about cosine and sine because we know that in an ordered pair, cosine comes first and sine comes second. If it helps, these are both alphabetical, right? X and Y, cosine and sine. So we can think about our cosine and our sine, and we haven't talked about tangent, so we're going to have to come in, we're going to have to discuss that, but I'm going to make this into kind of a table because it's a little bit helpful to see that kind of stuff. See how I'm making this into a table for cosine, sine, and tangent. And now I'm going to fill in some ideas. We said in quadrant 1, remember cosine is our x coordinate. So quadrant 1, cosine is positive. Quadrant 2, cosine is negative. Quadrant 3, cosine is negative. Quadrant 4, cosine is positive. Remember, these are x values. Sine are y coordinates. Sine in quadrant 1 is positive. Sine in quadrant 2 is positive. Sine in quadrant 3 is negative. Sine in quadrant 4 is negative. Now this last guy. Someone's always got to be different, doesn't he? Our last one is looking at tangent. And a reminder over here, in case you probably don't recall this from Algebra 1, or maybe not from geometry either, but our tangent of an angle is sine over cosine. You may be wondering if that's really true. Should we prove it? Sine opposite over hypotenuse, cosine adjacent over hypotenuse. Dividing by a fraction tells us we're going to do a, copy dot flip-flop, if you remember it that way. Copy the top, multiply, flip-flop the bottom. The hypotenuse on the top is going to cancel out the hypotenuse in the denominator, and we're left with opposite over adjacent, which is, in fact, the definition of tangent, opposite over adjacent. So we can certainly prove that, right? No biggie. Tangent is sine over cosine. So I'm going to think about each of these tangents, and since I only care about the sign of it, whether it's positive or negative, tangent being sine over cosine means here that I have a positive divided by a positive number. Positive divided by positive is a positive. In quadrant 2, I have sine, a positive, divided by cosine, in this case a negative. And a positive divided by a negative is a negative number. Quadrant 3, sine and cosine are both negative, so I have negative divided by a negative. And just like negative times a negative is a positive, negative divided by a negative is a positive number. And last but not least, in quadrant 4, I have sine, which is negative, divided by cosine, which is positive. This will be a negative. So there's all kinds of patterns going on here, right? Positive, negative, 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 positive, 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 negative, negative, positive, negative, positive, negative. Every pattern we can come up with. So this will help us remember that we can do lots of calculations, and we just have to remember which quadrant we're in to make sure we get the right sign for each of our coordinates. Now a quick look at Andre's calculations and we'll be all set with lesson 6. Suppose that the angle theta in radians is in quadrant 4 of the unit circle. I am a visual person. I like to see where this is going to be. Somewhere down here in quadrant 4. And we just said in quadrant 4 we have positive, negative values. If cosine theta equals 0.28, what are the values of sine and tangent? Andre uses the Pythagorean identity and determines that the value of sine theta is negative 0.96. Maybe we're like thinking, oh, we can go to the chart, right? But we have a negative 0.28, not 0.26. So we can't even go and use our chart. Instead, I'm trusting that Andre is using his quadratic formula or Pythagorean identity properly. I can also double check it, because if he's telling me that cosine is 0.28 and he's saying that the sine is negative 0.96, I can do that math real quick, especially since I have a calculator. And it hopefully is going to equal 1 if Andre did his Pythagorean identity correctly. Remember, put that negative in parentheses before you square it so that it knows, your calculator knows it's doing negative times negative. And they do in fact equal 1, so I agree with his value of sine. Using the values of sine and cosine, he calculates the value of tangent, sine over cosine. So he takes the sine value, negative 0.96, and he divides it by the cosine value, 0.28. And he comes up with approximately negative 3.43. Let's see if we agree with Andre and if we can explain our reasoning. So it so far makes sense, looking up at my table up here, that quadrant 4, my tangent value and Andre's tangent value should be negative. So I'm going to say, first of all, tangent in quadrant 4 should be negative. And Andre's is. So that looks good. Second, we already know his values of cosine and sine are correct. His values of sine and cosine are correct and on the unit circle. We could tell that because sine squared plus cosine squared equaled 1. And let's just double check if he calculated this correctly, because that's the only place I can see him going wrong right now. Negative 0.96 divided by 0.28, and it does in fact equal a negative 3.43. Right, and so he calculated tangent as sine over cosine. So negative 3.43 is correct. So we could say yes, we agree. Andre's right, and we're good to go. Our section 3 was a card sort here. You can't do card sorts when we're doing a video lesson. So you're good to go. Get some practice. Thanks, friends.